Diana, she was cleaning the boards nicely. So I'm going to share it with friends, and then we'll come a few minutes later after that. As possible to share it with friends. I'm sharing it on Facebook as well. I'm sharing it on Facebook as well. I think you let's start. Let's start. Because before we wait to you feel to stand? Yeah. Okay. Okay, so we are coming to do the practical, some of the practical questions with, and when it comes to trigonometry, the practical questions when it comes to trigonometry, and usually the practical questions is basically about, most of the times it's about ladder problem. So that's what we are coming to do today. And can you come and check if maybe you will see me when I write, and can you see it? Can you see it? Yeah. You can see it clear. But the place comes back. Okay, but I think maybe you can see it. Okay, so let's start here. No, it's shaking. It's shaking. Yeah. No problem. It's because of our lighting system. The lighting is too low. The lighting is too low. Yeah, let's start. Why don't you use the ring light? The ring light is damaged. I have to fix it. After that, I'm going to fix it. I'm charging my email this one. When it's blinking, I will stop using it. Okay, so let's start. I hope you can hear me clearly. Okay, then you're about to go. So the practical questions, I told you that it's just about ladder problems. Ladder problems. Let's try this question. When you get a question like this, so you see that the trigonometry, I told you that it's about triangle, right angle triangle, like this. Right angle triangle like this. So we will take always, the practical problem is most of the times it's simple. It's a ladder. So this, you take this one as the ladder. This one, you take the hypotenuse to be the ladder, and maybe this one, and then this one will be the ground, and this one will be the wall, maybe this is the wall, this is the wall. So most of the time that's how it looks like. I mean, the problem looks like. So it's not something that is difficult. You have to just pay attention, then note each word that it will, and note each word that they will talk about in the question, Yes, so with the problem, let me say word problems is not difficult at all. Let's try this question. It says that a ladder leans against a wall, vertical wall, at an angle of 60 degrees to the wall. So look at here, a ladder leans against a vertical wall. So let's take this one to be the vertical wall, and this one to be the ladder. This one to be the ladder, the L, and then this is the vertical wall, W. This is the vertical, and then this is the ground. I think I should use this one. So this is the ground, and then so a ladder was leans against the wall, the vertical wall, at an angle. So since they said vertical wall to the vertical wall, the 60 does not supposed to be here. Have you seen? This is to the horizontal ground, but they are talking about the vertical wall. So it means the 60 is where here. So here is 60 degrees. So that's it. When you get question like this is very cheap question. And then it says that if the foot of the ladder is 5 meters away from the wall, the foot of the ladder, So what is the foot of the ladder? Either side. It's 5 meters away from the wall. Have you seen? Look at here. So where will be the 5? Down here. Down here. Yes. Down here. Please don't forget to share it. Share the channel with friends. I wasn't able to share it with so much friends, so try as much as possible to share it. If you are new here, subscribe to the channel so that will give you more questions and then updates on academics excellence. So this one is going to be 5 meters, and here is 60. Now they will ask you either to find this side or this. That's what you don't have, right? So let's take it out here. Now the question goes, calculate the length of the ladder. So what is the length of the ladder? It's going to be the what? The hypotenuse, right? So try and let me see. Try your hands on it and let me see. Fast, fast, fast. Try your hands on it. Try your hands on it and let me see. So you are calculating the length of the ladder. So usually these word problems are really easy. They are really easy. They are not difficult questions. You just have to pay attention to the each word that they talk about and then what they mean, why they brought a certain word in the question. Are you done? You're not done. But your calculator is there. You don't know what to do. Are you sure? Oh, but we already talk about SOHCAHTOA, and this is right angle triangle. You have 60 here as an angle. You have this side, and you are finding this side. Yeah, you are finding the hypotenuse, which is the ladder. Try, 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 try. This one we solved some yesterday. We solved, but that one, despite that, we didn't say ladder against the wall. We didn't say ladder against the wall. So try as much as possible to. When you get the answer, you can comment below so that I will know the answer that you've gotten. You can comment below. What did you get? Here. This right angle triangle. And you have one angle. You have the opposite, right? You don't know the adjacent. You don't know the hypotenuse. There is SOHCAHTOA here. This one yesterday we talked about it. So how can you use this one to find? How can you use this one to find the hypotenuse? So use it to find it. You can't do what? Which figures? But so this one you'll be getting sine 60 is equal to what? Sine 60 is equal to what? To 5 on h, right? And you are looking for h. So you just multiply both sides by h and then you divide both. In other words, yes, you multiply both sides by h. Then this one will take off this. Then you'll be having h sine 60 equals what? Equals 5. And even sine 60 here, sine 60 here is equal to what? Is equal to root 3 on 2, right? Root 3 on 2, right? So root 2 on 2h is equal to 5. You are looking for h. So this one time this one give us what? 10. So h we'll be having h to be equal to root root 3h is equal to 10, right? Then we'll be having h to be equal to 10 on root 3. So enter this one into your calculator. That's all. That's all, yeah. This is very simple question. This is very simple question. You had 5.8. Yes, so we'll be having 5 points. So 5.8 is the ladder, is the length of the ladder. That's all. That's all the question. So the practical problem is not practical application is not anything. A ladder leans against a vertical wall. A ladder leans against a vertical wall. If the foot of the ladder, if the foot of the ladder is 8 meters away from the wall, are you writing it? Okay, if the foot of the ladder is 8 meters away from the wall and the height of the wall is 10 meters, and the height of the wall is 10 meters, find I, the vertical angle, made by the ladder, II, the length of the ladder, Have you written it? Okay, so one, you are finding the vertical angle, the height, and then, sorry, the vertical angle made by the ladder. Okay, the height of the wall is 10 meters. And then you are finding the vertical angle made by the ladder, and then II is the length of the ladder. II is the length of the ladder. Oh, adi oyenzi, adi oyenzi. So a similar question, the same ladder problem. Where is the objective simple or there it will be imposing an answer. If you really learn, supposed to get the answer at least. Hurry up. So I write the dimensions. The question says that the ladder leans against the vertical wall if the foot of the ladder is 8 meters. Foot of the ladder is 8 meters away from the vertical wall. So the foot of the ladder, look at here, the foot of the ladder and then the vertical wall is 8 meters away. Have you seen? So this side and this side is 8 meters away. And then and the height of the vertical wall is 10 meters. So this the vertical wall is 10 meters. This is 8 meters away. 8 meters away. And this is 10 meters. This side is 10 meters. And the angle, let me check the angle. It says that, yes, and then you say you're asking to find the vertical angle made by the ladder. So what angle are they talking about? What angle? Here, where? Here? Here? Yes, so this is what they are talking about. So you are finding this angle. It's 6? It's not 6, so. You've solved it. You solved it. You solved a bit. This is what you've been given. Me having solved it. But obviously the length of the ladder should be 6. So after that, then you find it. But you can, so you find, you already gotten the I left in the I. Hurry up. You are finding the vertical angle, and then also the, yes, you are finding the vertical angle, and then the length of the ladder. This is simple question. Help so that you solve complex ones a bit. So that,
Oh yeah. I'm coming. It'll be 12.8.
And then check out for the other one. The angle, the vertical angle. What is the vertical angle? Daniel, please hurry up, hurry up. Because you too much. Hurry up, hurry up, hurry up. Don't get what? Don't get the answer. Why? This is simple, yeah. You are looking for this side. You have this side. So look at here and then, oh, this is theta. Theta is here. You have this side. What do you have? So use it to find it.
If I say I get 0 point something,
You won't get 0 point something. So you use tan, right? So
it looks like my son.
when talk about theta, Papa. I hate about program. But but you have tan inverse of, right? So you got tan inverse of 8 out of 10, right? And 9. That's so yeah, tan inverse of 8 out of 10 is equal to this question is simple. Question is man, you keep long too much. I know it's a calculator, but you keep long too. Just give me this answer. If it's tan inverse of just give me that answer. So now let's move on to another question. Maybe because me pen and come pen and come. Okay, so let's try this question. A ladder 5 meters long leans against a vertical wall at an angle 70 degrees on the ground. So leans against the vertical wall at an angle 70 degrees on the ground. The ladder is 5 meters long. It leans against the vertical wall. Oh shit. Then it leans against the vertical wall at an angle 70 degrees to the ground. At an angle 70 degrees to the ground. The ladder slips. It slips down. The ladder then slips down to the wall. Wow. It slips down to the wall 2 meters. Yeah, it slips down to the wall. Sorry, it slips down the wall 2 meters. Then you're asked to find equal to two significant figures, equal to 2SF. I. A new angle which the ladder makes with the ground. A new angle which the ladder makes with the ground. And then II. The distance the ladder slipped. The distance the ladder slipped on the ground from the original position. The distance the ladder slips on the ground from the original position. So let's know how you understand this question. Let's know how you understand this question. How do you understand the question? Have you written it? Hey, controversy. Okay, so read it and let me see. What of the ladder?
The ladder is 5 meters long.
Mhm.
Then it makes an angle from here.
Can you come and demonstrate it? Uh-huh. So you can stand this side so that we can see. You can stand this side writing this way. Uh-huh.
Then here is here.
You can use this marker. You should be say it should be higher. Uh-huh. So the way you're writing things, no, be better.
Then that is 70 degrees.
Which place is 70 degrees? Okay.
Then it says that then it's left.
Uh-huh.
So it is left and it's like this. It's like that. So and then I go from there. So then and just
No, just imagine how maybe if a ladder slips, if a ladder slips, how is it going to be? It's here, right? It slips down, right? So pass the car. Uh-huh.
to the other hand.
Uh-huh.
No one.
Is that how it's going to be? Is that a ladder? You see that a ladder? When a ladder is there, when a ladder is there like this, when it slips, this is the height. When it slips, it comes down. It means that this it will be like this.
Yeah, yeah.
Uh-huh. So that's how you should imagine it. That's answer. Uh-huh. So this one we can use this one as the broken lines, the second one as the broken lines, maybe like this. Uh-huh. Do you understand? And so it will form new angle here and then new distance from here to the ground. Have you seen? So here is the case that the ladder slipped. Let's watch it out. He said the ladder slipped 5 meters long. No, another 5 meters long leans against the vertical wall at an angle 70 to the ground. The ladder slips down to the wall 2 meters. So this is 2 meters, right? This is 2 meters, right? Uh-huh. Okay. Then find correct the two significant figures. The angle, the new angle formed, the new angle which the ladder makes with the ground. So which new angle does the ladder makes with the ground? Uh-huh. Not the ladder makes with the ground.
Maybe
This can you come and show me? Where's one now?
here.
This side, right?
Yeah.
Okay, this side. So how can you get this side? So now that's what you are looking for. And then the I is the distance of the ladder slipped back on the ground from its original position.
Distances went back.
Distance, yeah. They said Habi when it moved downwards, it will go backwards. And so they are saying that you should find the distance of the ladder slipped back on the ground from its original position. So which distance are they talking about?
This this
Which one? Yes, good, fantastic. Yes, so this is the original ladder. So this is the distance that they are talking about from here to here. So how can you get this side? How can you get this side?
this one here.
Which one?
This this here.
You take it from the here. So you're finding both the angle and then the distance.
Sorry.
Oh, sorry for what? It's okay.
So this one was
Mhm. Which one was the new angle?
yeah.
I mean, you're taking this triangle out.
No.
Okay.
Then the part middle I have the same length.
Mm-hmm. Good. So she said it has the same length when even it slips. I'm just repeating because you're not having the microphone. And then after that,
After that, I
so you're finding the angle.
I'll find here.
Right?
Yes.
Yeah, you're looking for the. But you see, there is no. distance here and here. So how can he get there? You see the same approach, the the law I taught you, the principles. Whenever you are finding a question. So how can you get there? How can you get there? So you see, come to. So I told you that whenever you are solving a question, you have to ask yourself, how can you use the information that you have, right? So how can you use this information, this two here, and then this angle here, to get both, either any of this one to get it? How can you use this angle? Or so you have this one with the 5. How can you use this 17 and these 2 meters? You said you should subtract these 2 here from the 5. No, but this 2 here is vertical length, and this is inclined length. You understand? So we can't do that. You can't do that in Libya. So I think you see the original. I was really happy when he said the ladder length maintains the same when it even slopes. But you should also take note that the vertical wall, the length too maintains the same. This is the vertical wall. So this vertical wall from here to here. Okay. So this vertical wall, look at here. From this side, from here to here. This vertical wall from here to here. It maintains in the same. Despite that we have been given a distance, right? But the vertical wall is still there. But you have been given the difference between the original one and then the slipped one. So in other words, when we're able to get the main length, we can deduct these two from it to get this side. Do you understand? Which is this side. And when we get it, that's all. We can able to do anything we want, right? Okay. So let's solve for that one first. How can we get this one, this length, the vertical height of the wall? How can you do that? We use what and what? I mean, what and what? I mean, what do you have here for us to use? Although you use cos, but what do you have here, and why should you use cos? The 5, the 2 here, you see, the 2 here is not, the 2 here is the difference. It's from here to here. Have you seen? The 2 here is from here to here. So let me say, this is not a triangle. This is not a right angle triangle. Have you seen? So we have to use this angle here, which is the 70. This angle here, which is the 70. We consider only this triangle. In this case, only this triangle. So you use this 70 and then this 5 as the hypotenuse. In other words, you realize that since you have 70, you have hypotenuse, and you are looking for what? You are looking for what? Hey, opposite. So you are looking for the opposite one, which is this side. So since you are looking for this opposite one, it means that what you are going to do is simple. That is, okay, sorry, the microphone went low battery, so I have to change it. Yeah, so look at here. Since we have yes, since we have the angle, so which is theta, we have the hypotenuse, and then we are looking for the opposite. We will consider what? What ratio are you going to consider? Sine, because sine have the opposite and then the hypotenuse. So that's what we are going to consider. In other words, we will use, it's going to be sine what? Sine 70 is equal to what? Opposite out of hypotenuse. The opposite is unknown. Let me use variables to represent here A, B, C. So AB here, which means I'm going to have sine 70 equals what? Length AB, right? Because you don't know it. Length AB out of what? Out of the 5, which is the hypotenuse. So length AB is going to 7 times sine 70. What is 7 times sine 70? Fast, fast. Yeah, 5 times sine 70. Hey. 4.7. Okay. So we're going to have AB is going to be 4.7. And AB is going to be 4.7. 7 what? So 4.6. You have to write 4.698. Now, okay. So whenever you are solving a question, you are not done. This is not the main answer. So you don't have to run it here. You understand? This is not the main answer. So you don't have to run it here. So you have to continue. Now you'll be able to find length AB. After getting length AB, then let's check out for here. Now it means that we can deduct, we can get here. Have you seen? We can get this side, which is the same as this side. So how can we get that side? So let me use maybe O here. Let me use O here. So OB, so we're going to get OB to be 4.698 minus what? Minus 2. So minus 2.000. We are going to have 2.698. Have you seen? So it means that this side is 2.698. Now after getting this side, we can get the angle, the new angle, which is here, right? So let's use angle to represent a theta. So we have this one too. We have hypotenuse, we have opposite. What ratio should we use to get the angle here? What ratio? Sine again. So we have it to be sine theta to be equal to 2 point, which is 2.698 out of 5, right? Out of 5, right? So we're going to have sine inverse of this. Sine inverse of this. So theta is going to be sine inverse of sine inverse of 2.698 all over 5. That's what you're going to get. Pardon? 32.6. So theta is going to be 32.6 what? Okay, 32.65. So it means that will be our new angle. So the theta here we are looking for, let me write it here. 32.65, right? So degrees. The next question was asking for something. It was asking for something interesting. It says you should find the distance between the ladder and then the slipped back on the ground from its original position, which is here, right? Which is here. So this one too, how can we get this side? How can we get this side? How can we get that? Share your opinion. Share your opinion. Share your opinion. Just say something. Trying is not a hammer. Trying is not a hammer. Try to say something. Say something. Don't say no idea. You're looking for this, I mean, this difference, which is on this line. So how can you get this difference? In general, if when you get BC, okay, let me use. Oh yeah, let me see. Here is D. If here is D, so how can you get CD? You find what? BD. So where is BD located? Look at the shape. How can you get BD from where? From where?
from
From
the new
the
angle.
new triangle, right? From the new triangle. So this new triangle, despite we reduce it, but that's not how it looks like in terms of so this is you can redraw it again if you are confused. You can redraw it again. Have you seen? And then here is what? Here is 5. This is 5 meters. This is 2.6698. So you're looking for where? We are looking. We have to look for this side first. After looking for this side, then you look for what again?
You look for
CD. Where is CD? CD. You can't find CD just like that. CD is not a triangle. It's not a right angle triangle. So we can't find it at ease like that. So what can you use?
what we should find.
How we are finding CD, right? So you said we should find BD first. So after getting BD, what are you going to do? You subtract CD. Do you know what you are talking about? When you deduct this one from the entire one, you get here. It's not what you are. This is not what you are looking for. You are not looking for BC. Mhm. Just continue what you are trying to say. That is correct. I just want you to say the right thing. Uh-huh. Do you understand what I'm saying? Like from here to here, from here to here, and we have here, and I'm looking for this side. You are telling me here is A, B, C. Yeah, this is A, B, C. And you are saying we should find AC. Come on. Good one there. AC. And we are looking for here. We said we should deduct this one from the entire one. Which means that we're going to get where? AB.
We should divide.
By division.
I
What you are saying is correct, but say it well. You don't understand.
okay, let's deduct.
Okay, let's take for instance, you have a bread. This is a bread. Weigh a pound. This is a bread. And then you are looking for what's in the entire thing. Look at here. The entire thing is, are you looking at here? The entire here is maybe 5 meters. If from here to here is 5 meters, and you are looking for this side, when you get this side, will you deduct it from this side to get this side? First of all, what are you looking for? You're looking for BC. You are looking for BC.
Deduct AC
Deduct BC from
from AC.
AC. You know what you're talking about. You are looking. This is what you are looking for. Why are you deducting from another one?
Then I'll deduct another one
Man kan fancy te o. Awɔ ɛhwehwɛ adze a ɛhwehwɛ BC o. BC na ɛhwehwɛ. Ɛma. So if you are looking for BC, but you've gotten it. Why are you deducting it from another one? If you have gotten it,
Then I won't deduct it.
you won't deduct anything. But this is long thing. You're supposed to deduct here more. I didn't know they able to. You have to break here from the entire thing. You have to break A, B. If there is a king here and you want only this side, I mean we break this one from it. So why is this one away rather? But that's what you are also in need of. Ata. So that's what you're supposed to do. So it means that you're supposed to find BC. Then after that you find what? B. You're supposed to find BD first. Then you get also BC. After getting BC, you can find the difference to get this side. Atasa. Atasi. Sure. Sure. So it's like this skin. The hand is like this marker. This marker, for instance. I'm looking for this, only this cover. I bet I'll take it from it. So make it for more two way now. So we make number 2 way because this is what I'm looking for. Yes. So since you will throw this one away, you are looking for this one. Then I measured from here to here. I've gotten the here. Maybe the entire is 5 meters. So if the entire marker is 5 meters, I'm looking for the top of it. Maybe I will break this one and throw it away. So it's the same as getting the BC and then deducting it from where? The entire thing. Because deduct na man you confused. It's a mate with you. Okay, it's answer. So yet so BC if you BD man, we are going to get what? CD. But do you understand? Guys, please, I'm sorry. So that is it. Do you understand now? Okay. So try it and let me see. So how can you get the BC here? How can you get the BC? You can use this triangle to get the BC. That's. So you use this triangle ABC to get this BC because you have the angle here. You use this triangle to get this side. Have you seen? Have you seen? Is that understandable? Say oh. This is what you are doing. You are looking for here, from here to here. Now here to this triangle, here to this triangle if you only need here. Okay. So this is triangle. I mean this is the triangle, the big triangle. So you are looking for this side, you are looking for this BC. This is the BC you are looking for. This is O. Everything. And then so we are looking for this BC. After getting this BC, you have to also find what? Find for what? Sorry, add a BD rather. Sorry. Add a BD. This triangle that I'm talking about. Everything. So this is BD. So we are looking for this side. After getting this side, then we also find this side BC. Have you seen? Then we deduct, yeah, so you're not the Ebuye for, we are breaking this one from there. Do you understand? Do you understand? Because the BD is the entire marker. B is the entire marker from here to here. And we are looking for only here. But before we get only here, we have to get the BC rather. And then we break it from it so that we get only this. Do you understand? So do it and let me see. Hope you can do it, yeah. Or you still don't understand? You still don't understand? Okay. So try and let me see. We are looking for CD. That's a CD. So it's like, okay. No, I won't do it. I want it to, when you get understand, you can able to do it. So we are looking for, look at it. So we are looking for, yeah, here is it. You are looking for, so look at here. This is the king. We are looking for, this is B, this is C, this is D. And we are looking for CD. We are looking for CD, right? We don't have CD. Before we get CD, we have to find BD first. After getting BD, are you looking at here? After getting BD, you have to also get what? CD. So when you have, okay, let me ask you a question. BD length, BD is equal to 10. Length BC is equal to 7. What is length CD? 3. How did you get the 3? So you deduct this one from this one there. Good. So that's what you are coming to do. That's what we are coming to do. But the case is that you have to get the BD first. We have not been given. And you can get it from this triangle. Everything. Into this triangle, in a minute now, what are they? So this is what you have around it. It's a right angle triangle. So what do you have to do from this triangle? you use, but there's no angle inside though. Have you seen any angle inside? And so why are you talking about the sine? So see, we have this side and then this side. So use Pythagoras theorem to do what? To do what? To get your BD. Okay. So after getting your BD, what are we going to find again? We are going to find what for what? For what? BC. So from this diagram, how can we get the BC? So, but if you don't want to get confused, can we draw it again? You can redraw the triangle. So this BC here falls in this triangle, right? So you can redraw the triangle again like this. You can redraw the triangle again like this. So this is the triangle. Here is 70, right? And then you know here to be. Have you gotten here? Have you found here, right? You got it as 4 points. So you can write it there 4.698. So you have an angle, you have 5 meters. So you can, I will advise you to use the original dimension that you were given. So what was the original dimension that you were given? The 5 and then the 70. You found it, right? So let me say, I will prefer you using this original one to get this BC rather. Do you understand? I hope you can use this one to get a BC, right? So you find the BC, then you find the B, then you deduct and let's see what you get. That's all what you're doing.